Hi everyone, this is section 2.3. The first thing that we're going to do is go over some geometry formulas. Before we do that, I want us to go over what the letters mean. Area is what capital A stands for. Capital V stands for volume. Capital S stands for surface area. We will not be using the capital B. L stands for length. W stands for width. B stands for base. R stands for radius. D is for diameter. And H is for height. So just looking at some of our formulas up above, one other thing is when we use pi, we're going to use the approximated value of 3.14. And the only other thing that I do want to add is the other way that we can look at a triangle formula is A equals and then using the decimal form. So 0.5 times the base times the height. Okay, looking at page 2. Recall that exponents are used to condense repeated multiplication. So instead of writing 2 times 2 times 2 times 2, we can write it as 2 to the 4th. The factor that is being repeated is 2, which is called the base. The number of times the base appears as a factor is 4, which is the exponent. Assume a and b are whole numbers and x and y are real numbers. So if we have x to the a times x to the b, we can write this as x to the a plus b. So when multiplying two numbers with the same base, keep the base and add the exponents. So here's another example. If we had x to the third times x to the fifth, that would be x to the 3 plus 5, which would give us x to the 8th. If we have, when dividing two numbers with the same base, you will keep the base and you will subtract the bottom exponent from the top exponent. So we would have x to the a minus b. So say we have x to the 7th over x to the 3rd. We would take x to the 7 minus 3, which would give us x to the 4th. So for this one, a number to the 0 power is always just going to be 1. This is true for all numbers except for 0. So if we have x to the 0, it's just 1. So as an example, if we have 5 to the power of 0, it is just equal to 1. The only one that doesn't work that way is 0. So 0 to the power of 0 is just undefined. When raising a power to a power, we will multiply the exponents. So when we look at this one, the b is raising the exponent. So when an exponent is raised to another exponent, we will multiply. So this would be x to the a times b. So say we have x to the 4th and then to the 7th power, we're just going to take x to the 4 times 7, so we would get x to the 28th. When raising a product to a power, you will apply the exponent to each factor. So if we have x times y to the power of a, we're going to have x to the a times y to the a. Say that we had xy to the power of 4, this would also look like x to the 4th, y to the 4th. Say that we have something maybe a little bit more complicated. We have x squared, y to the 7th, and that's raised to the power of 3. Then we would have it multiplying with both of these. So it would be x to the 6th, y to the 21st. And lastly, when raising a quotient to a power, you will apply the exponent to the numerator and the denominator. So we would have x to the a over y to the a. As an example, if we had x over y and it was to the power of 5, we would have x to the 5th over y to the 5th. Say that we have a little bit more complicated of a problem. We have x to the 6th over y to the 4th, and then the outside exponent is 3. Then we would have x to the 18th over y to the 12th. Okay, looking at this next part, we're going to write the expressions using exponents. So if we have 4 times 4 times 4 times 4 times 4 times 4, we're going to look at how many times it's multiplied out. So that's 1, 2, 3, 4, 5, 6. And so 4 is our factor, and the number of times it's being multiplied is going to be our exponent, which is 6. For this one, we're going to see how many times -2 is being multiplied out. And if we count, that is a total of 4 times. Now this time, -2x is going to be in parentheses because the -2, we want to show that it's being multiplied with everything, including the x as well. So -2x to the 4th. This one, x is being multiplied 4 times, so this would just be x to the 4th. Looking at part B, it says identify the base and the exponent for the exponential expression. So your base is what the factor that's being multiplied over and over again is. So in this one, your base is 15x. For B, your base is just x because only the 11 is being applied to the x. It's not being applied to the 14. This one you want to be careful. The negative is technically on the outside unless it's in parentheses. So the base in C is just 3. But the base in part D is -3. The exponent part is a little bit easier. The exponent in A is just 11. In this one, it is also 11. In C, it is 2. And in D, it is 12. For part C, you're going to use the product rule to simplify the expression and write the result using exponents. So for this, we have multiplication with the same base, so we're just going to add the exponents. So we would have 7 to the 13th. For part B, the coefficients, or the numbers that are in front, we're going to just multiply. So we would have -42. And then with the variable here, since it's the same variable, we're going to take, and since they're being multiplied, we're going to add the exponents. So we're going to have -42 p to the 17th. These all have the same base, so we can just add the exponents. So 7 plus 2 plus 8, we get w to the 17th. For part D, you're going to use the power rules for exponents to simplify. Write your answer in exponential form. So if 5 is raised to the power of 4 and then it's raised to the power of 4, we're going to have 5 to the 4 times 4. So we get 5 to the 16th. If you have more than one thing inside the parentheses that's being multiplied, both factors will get the exponent. So we will have 7 to the 6th, t to the 6th. Same with this one, the r and the t will both get the 3, The 4 on the outside will not, because it's on the outside of the parentheses, so it will not be affected by the exponent. So this would be 4r to the third, t to the third. For part D, both the numerator and the denominator will get the exponent of 5. So we get r to the fifth over s to the fifth. For part E, anything to the power of 0 is 1. So for this, 4 to the power of 0 is 1. 10 to the power of 0 is 1, so that's 1 plus 1, so we just get 2. This entire thing is to the power of 0, so the entire thing is just 1. For this part, we're going to divide the coefficients. So 6 divided by -3 will give us -2. And then we will take and subtract the exponents for the x terms. So this will be -2 x to the third. And for the last one, same thing. We're going to divide the coefficients, so we get 2. And this is an invisible one, so this will be p to the 3 minus 1, so we get 2p squared. This next page has some more challenging ones, so we're just going to take it problem by problem. Okay, for this one, you can first work out what's inside this parentheses, because you have x's of the same, so they are the same base. So those can be multiplied, so we will add the exponents to get -3 x to the 7th, and now we can multiply these together. So I'm going to multiply the coefficients, so I get -18, and I'm just going to add the exponents. So I get 18x to the 9th. For number 2, we're going to distribute or apply the 4 that's on the outside. So if we ever have a 4 that only belongs to something that's more on the outside, it will be applied to everything. So it'll be applied to the -2, and it will be applied to this part, the x to the 4th. So that'll be x to the 4 times 4, because when we have a factor to another factor, we're going to multiply. So -2 to the 4th, we get 16, and then 4 times 4 will be 16. So it's 16x to the 16th. With this one, before we want to use the quotient rule with dividing, we want to work out the bottom first. So we're going to have multiplying here because it's a power to another power. So we have x to the power of 6, and now we can subtract. So we can have x to the 15 minus 6, so we get x to the 9th. For this one, we want to be able to use the quotient rule. So when we see the same base, we can just subtract. So this will be a to the 4 minus 1 and b to the 5 minus 2. So we get a to the third, b to the third. For number 5, we can first go ahead and distribute the 2 to all of the parts. So we're going to distribute it to every single part. So this will be 4 to the 2nd, x to the 2nd, y to the 6th, and then the bottom will be 8 to the 2nd, y to the 2nd. If we work out those parts, we get 16, so we're just squaring those. 16x squared, y to the 6th, over 64, y squared. We can simplify the coefficients in the front to give us 1/4. And then we can also use our quotient rule to subtract here. So we get x squared, y to the 4th, over 4. We technically don't need the y squared on the bottom anymore if we just took away the 2 from the 6. For this one, we're going to apply the outside exponent to each of the parts. So it's going to be 5 to the third, x to the third, y to the 15th. And 5 to the third is 125, so we have 125 x to the third, y to the 15th. For number 7, this is just multiplying, so we're going to multiply the coefficients. We get 34, and then we're going to add the exponents. So we're going to have 2 plus 5, so we get 34 x to the 7th. This one, you're going to apply the outside exponent to each factor on the inside. So this is going to be 4 squared, and then x to the 4 times 2. So we get 16 x to the 8th. Same idea with this one, negative 5 to the power of 2, and then we're going to have x to the 6th. So this ends up being 25 x to the 6th. For number 10, the entire thing is to the power of 0. So this is just going to equal 1. With this one, the negative is outside of the 8. So if it's not inside the parentheses, the negative is on the outside. So we would think of this as negative and then 8 to the power of 0. So we would have the opposite of 1, which just would be negative 1. For this next one, we're first going to apply the outside exponent to each part on the inside. So we get 3 squared x to the 8th over 6 squared x to the 6th. If we square the actual numbers, we get 9 x to the 8th over 36 x to the 6th. If we simplify the 9 over 36, that is just 1 over 4. And then we can just subtract. So we get x to the 8th minus 6 all over 4. Since the x minus 6, that part was subtracted, so we get x squared over 4. For 13, before we apply the quotient rule, we want to work out the top. So if we work out the top, we get 3 squared x squared y to the 4th, and the bottom is 3y to the 3rd. So we get 9x squared y to the 4th over 3y to the 3rd. If we simplify the 9 over 3, that's the same as 3 over 1. And then if we take x squared, there's no other x term, so that would just stay at the top. And then if we simplify the y part, that'll be y to the 4 minus 3. We no longer need the 3 on the bottom because we used it when subtracting. And if we get just 3x squared y to the 1st and it's all over 1, we don't have to leave it over 1. We can just keep that out because it's kind of just assumed. And we don't need to show that it's to the power of 1. So this can be just written as 3x squared y. For this one, before we multiply both of these parts together, we want to first apply this exponent. So this will be 4 squared x to the 4th, y to the 4th, z squared. And then it'll be multiplied with the front. So this will be 8xyz multiplied with 16 x to the 4th, y to the 4th, z squared. Now something to keep in mind is now that we're going to be multiplying these two parts together, we'll use the product rule, which tells us to add the exponents. So these invisible exponents are 1. Now we're first going to start by multiplying the coefficients or the numbers in front. So 8 times 16 gives us 128. And then if we add the exponents, that's 1 plus 4, so we have x to the 5th, y to the 1 plus 4, so that's y to the 5th, and z to the 1 plus 2, we get z to the 3rd. Okay, for the next problem it says, find the volume of a cylinder with a radius of 4 centimeters and a height of 8 centimeters. Include units in your work. So I'm actually not going to be too particular about this. It tells us that we're going to be finding the volume of the cylinder. The volume of the cylinder, the formula from the front page, is volume equals pi times r squared times h. So we need to know the radius and the height. So r stands for radius and h stands for height. So r will be equal to 4 centimeters and the height is equal to 8 centimeters. When we use pi in the formula, we're going to be using the approximated 3.14. Okay, so if we apply everything to this, we're going to have 3.14 times the radius squared, so that would be 4 squared, times the height, which is 8. Okay, if we work that out, we're going to have 3.14 times 16 times 8. And if we multiply all of that together, we get 401.92. And when we're dealing with volume, our units are going to be to the 3rd. When dealing with area, units will be squared. So this will be centimeters cubed, or to the 3rd. For number 2, it says find the area of a triangle whose base is 5 inches and height is 20 inches. Include units with your work. So again, we're not going to worry too much about including the units with our work. So the area for a triangle is 0.5 times the base times the height. So we will have 0.5. The base is 5 inches and the height is 20 inches. So we're going to have 0.5 times 5 times 20. And we can just multiply all of that together. And we're going to have 50. And because it's going to be the area, it's going to be inches squared. Okay. We are not going to deal with problems that deal with a fractional exponent, so you do not need to worry about the rest of those notes. If you have any questions, please feel free to reach out and let me know. Have a great day, everyone.